first estimation, just we'll review rounding. Started, yeah. So like with a lot of things we've done in this past chapter, the idea of place value is super important. In order to talk about rounding, we got to know several places. So we want to make sure kids are familiar with their place values, which they should be. And then one way to talk about rounding is just to look at number line. And let's say we're looking at numbers in the 50s. So up to 60 there. So if we have a number in the 50s, for sure, it starts with a 5. Now, 55 is kind of in the middle. And so when we talk about rounding, if the digits are from 55 and above, we say we round up, right? On the other hand, if it's below 55, that's supposed to be a curly bracket. Like that. We call it rounding down. So for example, if our number was 54, we would round that down and call it 50. If it was 57, we would round that up and call it 60. What would we do if it was exactly 55? What's that? Yeah, we round that up too, so that's going to go up to be 60. So another way to talk about it, aside from balancing on the number line, is just a rule. So round up if the digit to the right is a 5, a 6, a 7, an 8, or a 9. So that's 5 of our digits. And we round down. If the digit to the right, let's see, wrong way. Yeah, no, right, that's right. Digit to the right is 0, 1, 2, 3, or 4. 10 choices for digits, 5 of them go down, 5 of them go up. Now, one thing kids get confused on here, so something that'll pop up, and you'll just have to deal with it when it does. The idea of rounding down, really all we're doing there is dropping that digit and replacing it with a 0. Whereas when we round up, we're actually changing the place that we were at. And so some kids will have a tendency to want to drop that 50 to a 40. Right? And the easy correction is just show them on the number line. Which 10 is closer, 50 or 60? Right? 40 wouldn't even play in here. Okay? And so it's an easy thing to correct, but it's a pretty common misconception in terms of rounding. Now, with respect to rounding, you guys are going to be professionals soon. You're going to be using spreadsheets often. So I just wanted to demonstrate rounding on a spreadsheet. So suppose I have a number like 5,857. Blow that up a little bit. Oops, too big. Thank you. So one thing I can do is use the round feature. And so with a spreadsheet, you can start your formula by just typing equals, pick the beginning letter, and then the spreadsheet will tell you all things that start with R. And my screen's kind of small, so it's not showing me what I want to see. Now they also have most spreadsheets have a round up and a round down feature, because sometimes you just always want to round up to be safe. Other times you always want to round down to be safe. So that's an option too. Or you can just follow the rules. And then there's places that you can round to here. Now the 1 represents decimal places. So this is mostly designed to deal with fractional numbers, not necessarily whole numbers, but you can force it to deal with that. So what I do then is say, okay, here's my number. Since there's no decimal places, like if I wanted to go to the nearest 10th, I would type 1 decimal place there, and it would round it to the nearest 10th. Now there's no change there. If that number was 57.5, then it's going to round that. Let's go 5, 6. So it's going to round that 10th to the 6th place. You can, however, so if decimal places would be, this is the first decimal place, that's the second. Changing direction, you just go negative. So if I put a -1 in here, then what it's going to do is say, oh, don't go to this decimal place, jump to this side instead. Okay, so it'll call that the place we're looking at. What would I do to round to the nearest, so that would round to the nearest 10th, what would I do to round to the nearest 100th?
Make it a negative.
Make it a -2. So I would just come back here, instead of a -1, I'd say go 2 places to the right to do your rounding. So -2. So there's kind of a cheat way to do that in there. But by default, the system is mainly designed to do decimal type numbers, but we can make it do others. So it's a good thing to know. So again, to make that round there, the formula I typed was equals rounds. I gave it some number to look at, like 5857.56, oops, 0.56, comma. Normally, if I type a 1, a 0, 1, 2, 3, and so on, that'll pick a place to round. If I go -1, it'll start jumping the other direction and looking places to round. So that will round to the nearest 10th. And you'd think, well, I'm teaching elementary school, I'm not going to use a spreadsheet. You probably will in some grades. For example, I was shocked like 5 years ago when my daughter was in 2nd grade and they were teaching them to type so that they could do online writing assessments in 2nd grade. Seemed nuts to me. It still seems nuts to me. However, computers are everywhere. Kids are learning to use them younger.
They use iPads.
They use iPads in kindergarten, yeah. So the technology is going to be out there. I'm pretty sure by the time you guys are teaching in certain grades, you will be using spreadsheets. So best to start learning now if you haven't played with it before. All right, so rounding's pretty basic. You're all pretty good at that. You've been doing it forever. We don't always round though. So there are other ways to approximate numbers. So we're going to play with some other techniques. The biggest one that's used, and this is used in banking a lot, is the idea of truncating. And truncating is essentially the same thing as always rounding down. So for example, if I take the 5,857 I had earlier, and I wanted to approximate to the tens parts, or truncate the ones, I don't even care what the ones digit is. I just get rid of it. So I would say truncating that would be 5850. Care what the digit is. And that's an approximation practice. We just drop one of those digits there. It's not significant. So if you've taken a science class, you probably did some significant figure work. That means certain digits just don't matter. We don't have enough information to know if that 7 is really important or not, so we just ditch it and we replace it with a 0. And so the spreadsheets have two ways to deal with that. One is the round down feature we just saw a minute ago, and the other one's to actually do truncate. So the command is called trunc. So I would start typing TR, and it says, hey, do you want to truncate a number? And again, truncate just means chop it off. And if you click the question mark, it'll try to explain what it does. And it's related to the idea of significant figures in science. That if you measure something and you're only confident to the nearest hundredth, that means you only have 3 significant figures. It's not important that you're to the nearest hundredth, but there's three values that you're sure about. So therefore, any calculations you do with that, if you were to take the 3.14 and multiply that by 27, I get a new number that has 4 digits. The problem is I started with only 3 significant digits. That means that 8 is meaningless. I have no idea if it's relevant or not. So we would just call it 84.7. Okay, so that's the idea of significant figures, which relates to truncating. And truncating works like rounding does. You give it a number. It could be a number in a cell, or you could type the number manually, and then you tell where to round to. Now, typically, it's expecting a decimal place here. So if you want to get into a whole number place, you got to go negative with it. So if I wanted to get rid of the ones, I would do a -1 there. And it would say, okay, dropping the 1, that's what I get. So this one, if I do the same thing, so rounding, it would be 5,860. Truncating, it would be 5,850. Okay. And so rounding is, truncating is something that you will come across in a lot of different places. So I have to give it a number like 5,857.56, and then I have to tell it what place to use. Oops, and I lied in the example above. It's not nearest 10th, it's nearest 10. And with truncating, we really can't say it's to the nearest 10 because we didn't consider that. Rounding does consider that. Here it's just I truncated to the tens place. Okay. Round down would do the same thing. So I'll just show that. Equals round, down. Then I give it a number, and I tell it what place, and it'll give the same answer. So that's another option. And I'll share this spreadsheet if anybody wants to review it. And whichever place you want. And that's the tricky part, the place. Okay, so kind of boring, but important information nonetheless. So as far as truncating goes, that leads to some other estimation strategies. And one that's very popular that you're guaranteed to see in just about every grade is the idea of front-end estimation. So if I had, for example, 2,576, and I wanted to add that to 3,257. With front-end estimation, again, because we read from left to right, we're going to call the left side the front. We only worry about the thousands. So front-end estimation here, the first attempt would be to say, well, this is about 2,000, and it uses truncating. You just look at the digit, plus 3,000. Oops. And so it's about 5,000. Okay. So front-end estimation involves truncating. You don't worry about rounding. You just look at whatever digits are in a position that you're interested in and use those. Let's get some serious bass going. You guys hear that? Mm-hmm. Now, you can adjust a front-end estimation by just taking into consideration the next spot. So then you can look over here and say, oh, well, there's 500 and 200, that's 700. So you can make adjustments to it by just moving right. So we could take the 500 and the 200 and just add that on. So we're right underneath. So then I could have 5,700. And you can do front-end estimation on pretty much any operation. You can do it on subtraction, multiplication, division. So we'll try it on a multiplication problem next. And if I needed to adjust further, I would just move to the next column to get a better estimate of it. Right? It's not rounding, but I'm zooming in on the answer. Have we done anything like this before? Answer's yes. When?
Front-end subtraction and addition.
Yeah, front-end subtraction and addition, sometimes called the Hindu method for that. Yeah, this is just the Hindu method. You just take it one place at a time, going from left to right. Yeah, that's all it is. All right, let's see, multiplication. Suppose we take 1,234 times 654, and we'll do a front-end estimation. And we'll start with the hundreds. So then I would say, well, this is pretty close to 1,200 times 600. And again, we just truncate. We don't make a decision about rounding. We just go with that. And then 12 times 6 is 72. So we have a little mental trick we can do because of the zeros, and then we just tack on our 4 zeros. And so first front-end estimation here gives us that. If we want to continue the front-end estimation, we could then bring in multiplying with tens. Now, then it gets a little bit trickier because multiplication, there's some distribution that goes on, right? Remember our grid that we drew? It's kind of complicated. It's not as easy as the addition. So extending this one's a little trickier because taking 1,230 times 65, or sorry, 650, is not the same as just taking, say, 30 times 50 and adding that on, because there's more interaction going on there. Okay? So it's a wee bit harder in this case, because I do have some work to do. I've got to multiply those 3 by those 2, and then tack on the zeros. Okay? So with addition, adjusting a front-end estimation is pretty straightforward. With multiplication, it's quite a bit trickier, but it's still easier than the original problem, right? Because I have fewer digits to multiply together. So you want to be careful. And let's just double check that. Whip out calculators right now. We don't need to do this by hand at the moment. What is 123 times 65? And then we need to tack on the 2 zeros here, right? So I get a better estimate of where the number's going. Now, my point a minute ago was, unlike the addition, where all I had to do is look at those 2 places and tack their sum on, multiplication's way more complicated. 30 times 50, well, think about that. 3 times 5 is 15. 2 zeros means it's 1,500. Is this new number 1,500 bigger than the previous number? No, it's way more, because multiplication is more complicated. That's why we had to do those crazy grids the other day. Okay. So just note, you can adjust, it's just harder than it is with addition. Adjust, but it still work. Now, we can take ideas of round up and round down to get a range. So there's another technique called range estimates. And with range estimates, you pretty much go for a high and a low. So we do both around and we do a round down. So suppose, for example, I had 84 times 37. My round up, I would say this is 90 times 40. 9 times 4 is 36 with 2 zeros. For my round down, I would say it's 80 times 30. 8 times 3 is 24 with 2 zeros. And so what I end up with is a high, an overestimate, and a low. So the actual answer has got to be somewhere in the middle. Why would we bother doing this? Anybody thoughts on that?
Could it be used in data if you don't know what outcome?
Yeah, you can use this to estimate an outcome. Yeah. How many people never push a wrong button on their calculator or phone? Computer, right? We all do. If we push the wrong button, we're gonna have the wrong answer. At least if we can scan something and like visually get a quick high and a low, we'll know if what we typed is in the ballpark, right? So this gives us some ballpark ranges to look at to come up with that. So it's always a good idea to have these mental estimation strategies just to know if the work we're doing is making sense, okay? All right, let's see, what other tricks do we have here? Front-end estimation, high and low. All right, so a couple other strategies. We got a few more to go, and then we can do some review. Compatible numbers. So compatible numbers are just numbers that work well together. So if I'm adding a bunch of numbers like 3 and 8, not add yet. 3, 8, 4, 7, 6, 2. With compatible numbers, we just look for numbers that work well together. Instead of going 3 plus 8 is 11, plus 4 is 15, we might go, hey, 3 and 7 are nice. 8 and 2 are nice. Oh, look at that, 4 and 6 are nice. I just made a whole bunch of 10s. So I've actually covered all the numbers coincidentally, so the sum has to be 30. Right? So we find numbers that are compatible. In this case, with addition, we're looking for numbers that make 10s. 3 and 7 is a 10, 8 and 2 is a 10, 4 and 6 is a 10. So there's compatible numbers. Similar trick is involved with multiplication. If I had to multiply 2 times 3 times 5, although I could go the regular order, 2 times 3 is 6, times 5 is 30, I kind of like to look at things and say, well, that's a 10 right there, so the answer's got to be 30. So we look for numbers that are easily compatible, and usually it's things related to 5 and 10 with compatible numbers and multiplication. All right. Next one. Breaking and bridging. So suppose I had 384 and I want to add that to 75. Breaking and bridging, you just pick a spot to break, and usually it's like the 1s or the 10s place, and you just split the problem up into parts. So maybe I'd break there. So I would do 380 plus 70, and that's going to give me 450. And then I would consider the 4 and the 5 as 9, and then put it together for the 459. And so these are things you can do on paper or in your head to try and come up with it without writing stuff down. Can you break in more than one spot? Totally. So we could break at every spot and say, okay, we've got 300, we've got an 80 and a 70, which is 150, and we have a 4 and a 5, which is 9. Now, usually for me, on a good day, I can keep track of 3 facts right in a row, but some days I can only do 2 facts and then put them together. Right? Have you ever done that? You're working on a problem and you get the first part, then you move on to the second part, but you forgot what the first part was. You go back and do that again. So it just kind of depends on the focus of the day. So there's lots of ways to break and bridge, to put stuff back together. Another strategy. So some of the strategies involve things we do mentally. That was like half of what we've done here, and others are things we write down. Anybody remember scratch addition the other day?
That's the one where you you add up to 10 and then you cross the number.
You cross out, yeah, when you get a 10. So if I was going to do scratch addition on this, I would go 7 and 4 is 11, scratch, because I found a 10. And then I only have to think about the 1 from the 11. So 1 and 5 is 6, and 6 is 12, scratch. So that was a 12, so 2 and 7 is 9. Those 2 scratches means I have 2 over in this column to deal with. And you can write it up there or just think it. 2 and 2 is 4, and 5 is 9, and 9 is 18, scratch. The 8 moves on. 8 and 7 is 15, scratch. 5 and 5 is 10, scratch, put the 0 down. And then consider the scratches. 1, 2, 3, that must be 310, so this must be 309. Is it a big benefit? I think so. Sometimes when I'm going through something like this, I go, 7 and 4 is 11, and then 5 is 16, and then 6 is 22, and then 7 is 29, or was it 39? Oh crap, I forgot where I was. Right? It's easy to lose track of that second digit, so the scratches help you keep track of it. Okay, so that's kind of a mental / paper way to keep track. Those are all the main estimation and mental math ideas I have. Does anybody here have any tricks that they do in their head for certain kinds of math that you can think of? So I'll give you an example of something I do. Every once in a while I'm doing something and I have to divide by 5. So my trick for dividing by 5 is in my head, I double the top number, which usually douubling is not that bad. So if I double that, I'm going to get 462, and then I just put a decimal point right there. And so the answer's got to be 46.2. The way my trick works is if I double the top of a fraction, I really should double the bottom. And if I double the bottom, what am I now dividing by? 10, and dividing by 10 is just shift the decimal point. So that's a quick way for me to divide by 5. Double and then move the decimal point at one spot. So that's a little mental math trick I picked up once upon a time, and I use it whenever I have to divide by 5. Got a calculator. Does that stir any memories of tricks you guys might do?
When I'm working, we have discounts at my store, and people always want to know what 30% of $45 is.
Oh, okay.
So I times it by 7% of each 10 and add it together in my head.
Yeah. So like for 30% off?
Of $40 would be 4 times 7.
Okay, so what's left over? Yeah, that's a good one. So with percent off, like suppose we have 30% off on a sale, that means you have to pay the remaining 70%. So you can just multiply by 7 and then move the decimal point. Yeah, that's a cool one. Yeah. Yeah, when I shop with my kids, they always wonder, how do you know about what the sale price is when they just tell us what's off? And I try explaining it to them, but they're too young to quite get it yet, but maybe they'll figure it out soon. Yeah, so that's a good one. Okay, anybody else think something? at the moment. So just think about it a little bit, because there could be a question on the test that says, hey, bonus if you can come up with some cute mental math strategy that you've done sometime in your life. Just think about it. Let it float around. Okay, so I'm going to pause this recording here for Nikki.